Hey students, in this video I'm going to explain the notes of 7.4, which is our about inverse variation. And before I go over the notes, I want to just clarify what inverse variation is. You were taught direct variation in Algebra 1 because it creates a line. It looks like y equals kx, so it creates a line for linear functions study. This inverse variation is what we're studying now because we are studying rational functions in class. So this equation of y equals k over x is the one we're going to be working with. So the k represents a constant of variation, which means that the relationship between the x and y values that you're going to have either in a graph or a table or in situations that are described to you or in real world situations, the relationship between those two variables are related with this constant. And specifically, it follows this format of y equals k divided by x. But as we know, we could find other values if we have the other two using the inverse operations. So that's what we're going to do. We're going to just multiply and divide. Here is an example of a table where x's and y's are given to you, and they're asking you to determine if the following table represents inverse variation. So as soon as you're being asked on the topic of inverse variation, write the equation of y equals k over x. And what you're going to do is substitute the values you're given to find the one you're missing. So here you're given x and y values. That means we are missing the k. I'm going to highlight the k. That way it can be pretty obvious what the constant of variation will be. So here, if we use this first example, we are going to substitute a -4 into the y. And then we're going to substitute a -9 into the x. And what this means is that we have a number being divided by 9, and it's going to equal -4. So thinking about this, the inverse operation of multiplication, excuse me, will give you that number for the constant. Here it's divided by -9, so to undo that, we want to multiply by -9. And as you know, what you do to one side of the equal sign, you have to do to the other as well. And this multiplication of -9 cancels the division of -9. And it results in your x multiplied times your y will result in your constant of variation. So I'm going through this example in detail for you to understand that we can also simply just multiply x times y equals your constant. In this space in your notes, I want you to write that x times y equals your k, your constant. So what we need to understand is that this relationship could also be seen like this. So now let's use this one to help us find the constant of variation for all these combinations of x and y's. And if the same constant applies to all, then this is inverse variation. If there is a different constant between any of these, then it's not inverse variation. So we're going to check by multiplying, and again, -9 times -4 gives us positive 36. That will be your constant here. And then we have -18 times -2. That also gives you positive 36. Then you have -6 times -6. That also gives you positive 36. And -12 times -3 also gives you positive 36. So here, the constant of variations for all of these are the same number. That means that yes, this is inverse variation. So it is inverse variation. And it says that if so, what is the k? So the k we found out to be 36. So you want to practice these problems on the right side. I'm just going to go over the ones on the left side in this video. The next table, we are going to do something similar that we did here. It's asking to determine if the following table is representing the inverse variation. So again, x and y values are being given to you. If you multiply x times y, it will equal your constant. So we multiply 3 times 6, and that's 18. 4 times 8, and that's 32. So these two constants are not the same. So we are just not going to continue comparing the others. We are going to just state that these are not equal. So this is not an inverse variation. And this is all this part of the notes was asking for you to do, to practice identifying if it is or if it's not inverse variation. In the back, we have how this topic could be asked differently. So this question is asking if y varies inversely with x and y equals 3 when x equals 5, what is the constant of variation k? So as soon as you see that it varies inversely, you want to annotate to yourself the equation y equals k over x. And as you do that, remember that we discovered that also x times y equals your constant. Using any of these equations, answer what is missing. So it's asking for the constant of variation between these two. This equation helps you find the constant easier. So we're going to use that one. X times y equals your constant. 5 times 3 equals your constant. So your constant here is 15. 5 times 3 is 15. So that means our equation is y equals 15 over x. To verify this, you can always just plug it in and check. So if x is 5, 15 divided by 5 equals 3. So that confirms that this works. You're going to practice this also on these two problems, but let me just go ahead and go over this one more problem. If y varies inversely with x and y equals -2 when x equals 9, what is the constant of variation? So they're asking again for k, and as we notated, x times y equals k. And we're going to substitute 9 times -2, and that will give us our k. So 9 times -2 is just -18, and that will be your k. So y equals -18 divided by x. That's all these two questions we're asking, so please practice that as well here. Another way that this topic could be asked is like this. If y varies inversely with x and y equals 6 when x equals 4, find y when x equals 8. So here we're going to calculate the y when x equals 8. They are giving you, though, x equals 4 when y equals 6. So use these two values to calculate your k. So x times y equals your constant. We're going to do 4 times 6 equals your constant, so k is 24. Once you find that k of 24, you're going to annotate it as an equation, y equals 24 over x, and use this equation to help you answer what's missing. Y is what we're missing, so x is 8. We're going to substitute an 8 in there. We're going to have 24 divided by 8, and that equals 3. So your answer here is y equals 3. On this problem, it's asking you the same way. Find y when x equals 5. On this problem, they're asking you opposite. Find x when y equals 45. So let's try this one and see what happens. If y varies inversely with x, we are going to, again, keep applying the two equations we have. And they are giving you here also an x of 15 and y of 6. So when y is 6, x is 15. Use these two to multiply x times y and calculate the constant. 15 times 6 is going to give you 90. So here we're going to have that k equals 90. And that results in our equation of y equals 90 divided by x. Here we are asked to find x when y is 45. So you will want to substitute it this way. And then now you realize that 90 divided by a number is 45. So since we don't know what this number is, we can understand inverse operations can be used to help. So here we're going to reverse the division of x by multiplying both sides times x, and that cancels the division. And we're going to have x times 45 equals 90. And that's just saying a number times 45 equals 90. Or we can also divide both sides by 45. And this is saying x equals whatever this division is, which is 2. So some students pointed out that without doing all this work, they could still just simply divide 90 by 45 and find that missing value. So we discovered that you can also have x equals k divided by y. So these x and y's are interchangeable. As long as you are missing one of the variables, whether it's x or y, you want to divide your constant by that number that you do have. So keep that in mind with these equations. This is the original, but we found out that these two also work by moving the variables around. All right, so try this one for practice and find that x value. And then one more problem in this video is the real world scenario. Here you have heart rates and lifespans of most mammals are inversely related. When you see the sentence that tells you that they're related inversely, go back and identify what are the two things that they're talking about, because that will be your x and your y. So here they're talking about the heart rate, and they're talking about the lifespan. And because they vary inversely, we can write y equals k over x. A cat lives about 15.2 years on average and has a heart rate of 126 beats per minute. So these two are your x and y. What is the constant of variation? So it doesn't matter which one is which at this point because we are multiplying x times y to equal your constant. So whether this is x or this is x, it doesn't matter. We are going to multiply both of these. So 15.2 times 126. This will result in 1,915.2. So that right there is your constant. And you're going to use that constant to answer the question. A hamster has a heart rate of about 634 beats per minute. About how long will the hamster live? So they are giving you one of the variables. They're giving you the beats per minute. In this case, we labeled x as the heart rate. So how long is the hamster going to live? That will be the other variable, the y. As long as your constant is on the numerator, the denominator has to be the number that they're giving you. So you are dividing the constant by the number that they're giving you. So 1,915.2 divided by 634. This will give you the lifespan. The answer here was 3.02. So in conclusion, 3.02 years is the answer to how long will the hamster live. Okay, try this other real world scenario and let me know if you have any questions. I hope this video helps you understand inverse variation.